All right, this is the homework help for Honors Math 3, Unit 10, Worksheet 3, but this will go with the Objective A component, so we split it between A and B. So this is just going to cover up through question number 12, so graphing cardioids, limacones, and petals only. Okay, so let's go ahead and start with question number 2. So for question number 2, what we want to take a look at is, what type of graph we have, right? So that's one of the things that we have to identify. So when I'm looking at this, I'm looking to see that I have an addition here, and then I see that the numbers for A and B, so 1 and 2, are not equal to each other. And so 1 is smaller than 2, so then that means we are going to be graphing a limacone. Okay, and so again, I know that because we are adding or subtracting. If there was no addition or subtraction, it would be a petal graph. And then if 1 and 2 were equal to each other, it would be a cardioid. And remember, a cardioid is just a hybrid graph of a limacone. Okay, so it asks us to fill in the table of values. So at the very minimum, I want you to always fill in at least 0 and pi over 2. And so I'm going to just do that kind of off to the side right here. And so when I let theta equal 0, I would have r is equal to 1 plus 2 times the sign of 0. And so I'm going to go ahead and just take a look at my ordered pairs here. So at 0, that ordered pair is 1 comma 0. Sign is my y value. So then that means sign of 0 is just 0. And so then I would have 1 plus 0, which is 1. And so when theta is 0, r is equal to 1. So on my graph, I'm just going to go out one circle here. So it's going to be a really tiny graph. So I'm just going to go out one circle there. Okay, at theta equals 0. So that would be 0 right here. And then now I'm going to go ahead and evaluate this at pi over 2. So I would replace theta with pi over 2. So I would have 1 plus 2, and then the sign of pi over 2. So that ordered pair, so this guy up here, pi over 2 is over 0, up 1, excuse me, and sign is my y value, so that would make that y is equal to 1. So replace sign of pi over 2 with 1, and then 1 plus 2 is 3. So at pi over 2, my radius is 3, so I'm going to go out 3 circles, so 1, 2, 3. And then I'm going to go ahead and finish filling out the table for this particular one, but I don't need to do that, right? So I can go ahead and graph it without doing that table as well. So how would I do that? So I'm going to pause on the table part, and we're going to think about, okay, so how do I graph it if it wasn't, or if I didn't want to use a table, like if I start to kind of learn about that graph in general, okay? All right, so what I want to take a look at is I know that I have a positive sign, right? So if I look here, right, look back at the equation, I know that I have a positive sign graph, and I know that sign is positive above. So I know my orientation now. So I know in general that outer circle is going to go upwards towards the positive sign, and so will the inner circle. Ignore the fact that that's a terrible little graph. Okay. And so then now what I take a look at is I look at the fact that I have a 1, right? So my A value, or my constant, so A is 1. So now I'm looking here. So then that tells me where my shoulders are going to be. And so then I would go out a distance of 1 to the left and the right. So I already did the 1 on the right. So then I would also have a 1 on the left as well. And then I would add these two numbers together. So 1 plus 2 is 3. So that means a distance of 3, which gives me this value, right? So then I have one more thing I have to do. So then I subtract. So 1 minus 2, or 2 minus 1, because I was going a positive value, is 1. So then I'm going to go up 1 as well. So I have 2 diameters by adding 1 and 2, which gave me that one. And then my other diameter of my inner circle, 2 minus 1 is 1, which gave me that one, okay? All right, so then now let's go ahead and connect the dots. So we'll always go through the pole. So I'm going to have my outer circle and my inner circle. Okay. And then I have to label the start and the stop. So I'm going to switch colors here. So when I label that start and stop, I know that occurred when theta equaled 0, r was 1. So that would be this dot right here, and always in a counterclockwise direction towards pi over 2, because that's the way we travel, and then my next dot. Okay? All right, so let's go ahead and do a couple more points though, right? So we're going to substitute in those points. So when I go ahead and do that, so if I replace theta with pi, so I'm going to just do that. I'll just do that right here. Let me go back to that same color. So when theta is equal to pi, I would have r equals 1 plus 2 sine pi. So this is if I choose to plot points, right? And so then I know pi is over here on the left, and that ordered pair is negative 1 comma 0. Sine is my y value, so that would be 0. So 1 plus 2 times 0, or just 1. So theta equals pi would be 1, and then that would have given me that dot there. And then let's do one more here, so 3 pi over 2. So r equals 1 plus 2 sine of 3 pi over 2. So that would be down here. So that order pair is over 0, down 1, and then sine is the y value, so that would be negative 1. So 1 minus 2, which is negative 1. So 3 pi over 2 is at the bottom. And when it says negative 1, that means we would go away from 3 pi over 2. So we would actually go up towards pi over 2. And that's how I would get the inner loop's diameter. So this guy right there. Okay. And then 2 pi just goes back to 0, right? Closes the circle, so that value would still be 1. Okay? All right. So let's go ahead and just a reminder, so for part C and D where it says indicate direction, start and stop, that would be just, using a different color. Like you don't have to, you don't have to actually say, oh, here is my start and my stop, right? That's not what you have to do. You just have to have that extra color marked and labeled. All right, and then let's go ahead and take a look at question number 8. So for question number 8, when I take a look at this, so again, what I want to pay attention to is that I have, what type of graph I'm working with. So I know I have an addition or a subtraction, so that automatically makes it a cardioid or limacon. And then when I take a look at the fact that 4 and 4 are equal to each other, if I were to subtract them, I would get a 0, right? So when I add them, I would get 8, which would be the diameter of the outer loop. Subtracting them, 4 minus 4 is 0, gives me the diameter of the inner loop. So that means there's no inner loop, and so then that means the graph that I have is a cardioid. Okay, so then I will be graphing a cardioid. Okay. So I'm going to start by graphing this without the use of the table. But again, for the table at the very minimum, you should have 0 and pi over 2 filled out. All right, so for the cardioid, to graph it, so the first thing I want to do is figure out my orientation. So when I take a look at that orientation, I know that I have a negative cosine graph, right? I'm subtracting, and I have a cosine. And I know that cosine is negative to the left, so that means my orientation is going to be towards the left. So that's my general picture, right? So the first thing I want to do is find my shoulder. So I take a look at the 4 here, so the constant, and that's a 4. So A is equal to 4. So then on this axis here, the y-axis, sorry, I'm going to go up and down 4 units. So I will have a dot here and a dot here, right? And those are those shoulders that I just found, right? The shoulders. So now I want to find the diameter of the outer loop, so I add 4 and 4 together, so that would be 8. And so I know this isn't quite long enough, so I'm just going add a few more. I'm not going to actually do circles, but I'm just going to kind of mark it off as if there were circles there. So 4 plus 4 is 8. And then again, if I were to subtract 4 and 4, I would get 0. So I would have no inner loop, and then I would have a dot at the pole. And then I just try as best as I can to make it look like a cardioid. That kind of heart-shaped look. I'm going to make that a little bit bigger. All right, and then at the very least, again, I want to have my 0 and pi over 2 values, so let's go ahead and do that. So I'm going to let theta equal 0. So I would have 4, whoops, let me get an r equals on that. So r is equal to 4 minus 4, and then cosine of 0. And so if I look at my ordered pairs on my unit circle, so over 1 up 0, and cosine is that x value. So that would be 4 minus 4 times 1, which is 0. So then my start, right, is right there. And then let's do theta equals pi over 2. So 4 minus 4 cosine of pi over 2. So pi over 2 is up here. So that ordered pair is 0, 1. So cosine is the x value, so that would be 0. So 4 minus 4 times 0, or 4 minus 0, which is 4. And so at pi over 2, it was 4. And so the direction, right, towards pi over 2 with my start labeled. Okay, and then I can just kind of follow along and fill in the table now, right, since I have my graph. So if I didn't know how to graph using just kind of the a and the b values, I would fill my table in completely and connect the dots. Or I could choose to fill in the table afterwards. So now that I have this graph, so I would go to where theta is pi, so that would be here, right? So that would be my next dot of travel, which is there, and I got a value of 8. And then 3 pi over 2, so here's 3 pi over 2, so that's the next dot in the travel. And I can see that that would be 4, and it would be positive 4, wouldn't it? Because I have to go towards 3 pi over 2, 4 units. I wouldn't want to write negative 4 because it's going down. That doesn't make sense. The 3 pi over 2 is what gives you that downwards, and I have to head towards that downward movement in a positive 4 direction, right? So meaning towards it. And then 2 pi, of course, would be the same as 0, and so that would just be 0 there. All right, and let's go ahead and take a look at 2 more here. So we're going to start with number 9. So even though the directions in number 9 say to do a table of values, you do not need to do a table of values for the petal graph. Like even in the notes, we didn't do it that way as well. So kind of like ignore that part of that direction. Okay, so first of all, I know it's a petal graph because there's no addition, no subtraction. So then I would make sure I write petals because I have to say that what kind of graph I have. So to graph petals, the very first thing that we have to do is we have to take that R value here, which is 4, and I want to replace it, or excuse me, the A value, which is 4, and replace it with R. And what that does is that finds me my very first petal, right? So my first petal, so I'm looking for that location of when is the first time the radius goes out to 4, because the first time the radius goes out to 4 is where that petal is. So I'm going to take 4 sine 3 theta, and then I'm going to equal that to 4 and then solve that equation. So I'm going to divide both sides by 4. So I would have sine of 3 theta is equal to 1, and then I want to know where sine is equal to 1. And so let's see, we have those little values up here, right? We did those. So sine is equal to 1 when y is equal to 1, and that would be right here. So that is at pi over 2. Okay, so then I don't need that sine anymore because I just figured out where sine was 1, and that was at pi over 2. And then I want to either divide by 3 or multiply by 1/3. And I'm going to multiply by 1/3 because I have a fraction on the other side. So then that would be theta is equal to pi divided by 6. So that is where my first petal is, right? So I got that when r was 4, right? I replaced r with 4, and I got a value of pi over 6. So pi over 6 is about 30 degrees, so that would be somewhere over here. Let me zoom in just a little bit bigger there. And then I'm going to go out 4 circles. And then there's my first petal, right? So my first petal is the first time R is equal to 4, right? Because that's the farthest it's going to go out. And then I'm going to draw in that kind of teardrop shape as best as I can. All right, so then the next thing I want to do is I want to figure out what is my value for B. So I know I'm going to look, B is what I'm multiplying theta by, so I know B is equal to 3. And then that's going to give me my spacing and the number of petals. Okay, so let's go ahead and do that. So this is spacing and number of petals. So I know B is equal to 3, which is an odd number. So there really are 6 petals, right? There's always the double petals. It's just a matter of do you graph that double or do you just graph the 3 of them because the other 3 petals are going to be on top of it. And so because B is odd, that means there are only going to be 3 petals evenly spaced between 0 and 2 pi. So to find that even space, I would just do 2 pi divided by how many petals I'm actually drawing, which is 3, so 2 pi over 3. But I always want to get that common denominator just to kind of make it a little bit easier for me to work with. So I know that I have this pi over 6 that I have to work with. So then that means I'm going to go ahead and multiply by 2 just so I have that common denominator. So the spacing I'm actually going to use is 4 pi over 6. Okay, which is the same as 2 pi over 3. So then I'm going to take pi over 6 and I'm going to add 4 pi over 6 to it. So that would put me at 5 pi over 6, which is right before I get to 6 pi over 6. So we'll just say right around there. And then I'm going to follow that same circle and go out 4 units and then draw in my other teardrop. Okay, and then I'm going to add 4 pi over 6 again. So I'm going to take 5 pi over 6 and I'm going to add 4 pi over 6, which puts me at 9 pi over 6, right? So 9 pi over 6, if I were to reduce that, divide by 3, so a common denominator, that would put me at 3 pi over 2, which is this quadrantal here, right? So always try to reduce that a little bit just to make sure that if you land on a quadrantal, you graph it on a quadrantal. And so then again, I follow that same concentric circle out a radius of 4 units and then draw in my teardrop. Okay? All right, one more here. So last one, question number 10. So for question number 10, I know that I have a petal graph because I am not adding or subtracting anything. So for a petal graph, the first thing I always want to do is find that location. Where the heck is that first petal? And I know that first petal's radius is going to be 5 because my coefficient is 5. So I'm going to take my equation, 5 cosine 2 theta, and then equal it to 5, and then just solve that equation. So I'm going to divide both sides by 5. And then from there, I want to figure out, where cosine is equal to 1, and I know that that is at 0. So cosine is equal to 1 at 0, because that's the x value. And then divide both sides by 2, so then I get 0 divided by 2, which is 0. So then my first petal had a radius of 5, right, because that was the coefficient here. And then that occurred when theta equaled 0. So then on 0, so this is 0 here, I'm going to count out 5 circles and then put a dot, and that's where my first petal is. Right, so draw kind of that teardrop. And then finally figure out the spacing, and you're going to find that spacing through the number of petals. So when I take a look at my equation again, so what I want to look at is that B value, so that's that number in front of the theta, so 2. And so then I know B is equal to 2, which is an even number. So there's going to be 4 petals altogether, right? So double the petals, so 2 times 2 is 4. And then because it's even, I'm going to see all 4 petals. There's not going to be 2 graphed on top of 2. So then for my spacing, there's going to be 4 petals graphed between 0 and 2 pi, so 2 pi divided by 4, or pi over 2. So that just means all the petals are going to be on the quadrantals, right? Because we're rotating pi over 2. So every pi over 2, which is 90 degrees, which is all of our quadrantals, I'm going to go ahead and do all 4 petals out to that farthest circle in this particular problem, because that's 5 circles out. And I just realized I did not do my start and stop on any of these. So on on the petal ones anyway. So let me go back and do that real quick. So let me finish up number 10 here. Okay, so my first petal was here at theta equals 0, right? So my first petal, and so theta is equal to 0, so that was this dot right here, and then headed in this direction. Okay. All right, and my start and stop on this one, so I'm going to let theta equal 0 to find my start and stop. So let me go ahead and do that. So at theta is equal to 0. So then that would be r is equal to 4, and then sine 3 times 0. And then that would just be 0. And I know at 0, sine would be 0, so 4 times 0. And so that would be at the origin, okay, and then headed in a counterclockwise direction, so that would be on the first petal, so that would be right there, okay. All right, and that's it for this one.